So thank you everyone for joining this session. It's the top of the hour, so we get started. And for the next hour or so, we're going to talk about, or 15 minutes, we're going to talk about Bicep infrastructure as code for Azure. So before we do start, a quick thank you to all of the sponsors that made this event possible, as well as to the organizers who are, again, doing a great job organizing this Cloud8 Summit event. It's great to be back to be able to present at this edition again. So quick introduction to myself. My name is Freek Berson. I'm from the Netherlands. I actually live close to Amsterdam, and I primarily focus on end-user computing. So that's basically anything related to remote desktop services, to Azure Virtual Desktop, to VDI, Windows 365, and all other related technologies. I work as a product manager at Parallels, where I primarily focus on application and desktop delivery using our own technology, which I will not be talking about today. Because today it's all about infrastructure as code, which is something else I enjoy working with as well. Some contact details are on the slide. Feel free to connect now or afterwards. Twitter, GitHub, email, LinkedIn, that is all fine. I'm also a Microsoft MVP now for many years, and I wrote 2 books, and one of them is actually related to this topic as well, which is called Getting Started with Bicep Infrastructure as Code for Azure. Right, let's begin. Let's do a really quick agenda, because the agenda is not really that big, because most of this agenda will actually be live demo. So we'll do a really brief introduction into what infrastructure as code is, what ARM templates are, how that relates to Bicep and the Bicep language. But for the big part, this session is going to be live demos. So we'll cover how to get started with Bicep, but also how to get the most out of VSCode, Azure code editing tool when it comes to code completion and all of the extensions that are available for Bicep as well. And we'll take a look at some more advanced scenarios all the way to a new technology called deployment stacks as well. And it's going to be a short call to action in the end in case you want to get started with Bicep yourself. So real quick, hopefully this is familiar to most of you, but when we talk about infrastructure as code, we tend to talk about the process of provisioning infrastructure, similar to how you would do that for example, for software, right? So in terms of infrastructure as code, you have some kind of template or some kind of script that goes through some kind of orchestration, and in the end, there is an end result, right? Whether that's a virtual machine or a piece of storage or something related to security or Azure Virtual Desktop or whatever you are deploying. So that's the process of defining what you want to create and having some kind of orchestration in order to create that, in this case, in the Azure Cloud. So it's important to know the difference between 2 different types of code, right? So when we talk about imperative code, we talk about executing a sequence of commands. So in this case, you need to specify not only what you want to create, but also how you want to create it. So PowerShell is a great example of this, where each of the lines of codes is ordered in a very specific or processed in a very specific order. So you as the author need to make sure that that order is correct to get the correct end result. That's different when we talk about a declarative piece of code. So declarative, in case of declarative, you are only interested in defining the end result. So you're not interested in defining how that is actually going to be created. You're not defining how that task is completed. You just want to state, this is the end configuration. I want to create this virtual machine or this storage or whatever you want to create. You then pass that, in this case, template to that orchestration, and the orchestration will deploy it in the most fast way, in the most efficient way. So that's declarative code, and we'll get back to that a couple of times throughout this session, because as we'll see, Bicep is a declarative language. So before diving into Bicep, it's important to also know about ARM and ARM templates, in case you're not familiar. ARM templates have been out there for quite some time. I also have a lot of experience before diving into Bicep with these ARM templates. But in the most simple way, this is an ARM template structure you should know about, right? So we have a section which is called parameters, which allows us to define certain values we want to use during the deployment time. We have the option to provide variables and functions, but for the most part, you'll probably deal with the section called resources. So that is that declarative section where you declare the resources you want to have created with all of the properties and all of the values. And you have some options to also create outputs for the template as well. So if you take a look at the template structure, it's quite easy, right? It's not that hard to, to get your head around, essentially. That changes if you start actually using ARM templates. And if you're familiar with ARM templates, you probably recognize this because ARM templates are based on the JSON language. So that's JavaScript Object Notation, which means that you get a lot of syntax overhead, a lot of code complexity as a result of that language, translated into brackets and commas and semicolons and very specific things you need to worry about when declaring such a template. So Microsoft obviously also got that feedback, and that is why and how Bicep actually saw the light. So what is Bicep? If you're not less familiar, it is a domain-specific language, or short DSL, which allows you to deploy resources in a declarative way. So there is that declarative mention again, right? So you might be wondering, isn't it exactly the same as that ARM template does? And the answer is yes. Second question, you might be wondering, does that mean that ARM and ARM templates are going to be replaced by Bicep? And the answer there is definitely no, because Bicep is what we'll call transparent abstraction layer on top of ARM and ARM templates, which means that ARM templates will still exist, but the complexity is gone, and a lot of additional power and a lot of additional support for modularity is added to that language as well. So Project Bicep is actually how it started, and this is September of 2020. This is a tweet by Mark Kosunovich, who I'm sure everyone knows. He's the CTO of Azure, and back in the days, he tweeted that they were working on a new open source domain-specific language, codenamed Bicep. And here is that, declarative mention modeling again, right? So what they intended to do is have that language simplify the way you are authoring ARM templates. And that is also where that analogy comes from, right? So what is it that empowers the ARM? That is the Bicep, right? So that's where the name is coming from. So originally, it was actually only codenamed Bicep. It was never intended to be the full production name of the language itself. Long story short, it did end up as that name, which also allows us to have these great Bicep icons and logos and throughout the Bicep language. Makes it kind of fun, I think. So if we know that, where then we position Bicep in the Azure Resource Manager, or Azure structure or architecture, if you will. If you take a look at the diagram on the right-hand side, we have the Azure Resource Manager engine, the ARM engine, that one in blue. That is not going to go away. On top of that, we also still have ARM templates. Those are also not going to go away. But on top of that, we have the Bicep language. So here you can see that abstraction layer technology where we are not replacing ARM templates, but instead we have a layer on top, which allows you as the author of the templates to create and declare your resources inside the Bicep language, provide that Bicep file to the ARM engine, and the ARM engine will then transpile that into an ARM template and process it and deploy it. So that transpilation process, back in the days, for those of you who are familiar with Bicep 0.1 and 0.2 versions, you had to do that transpilation process yourself by running the Bicep build command, which essentially transforms or transpiles the Bicep file into an ARM template or JSON file. That's now fully transparent and automatically performed for you, which means that you can just author your Bicep file, throw it into the ARM engine, and the transpilation process will be automatically performed for you as well. Beyond the easy language and beyond all of the additional benefit that you get as part of that simplified language, there's modularity is also a big part of the advantage that you get here. So it allows you to extract pieces of code, put them into separate module files, and reuse them for other projects or other environments, or maybe share them with other colleagues or other departments as well. And we'll take a look at some of those examples. And the entire project is open source, which means that all of the Bicep language is available on GitHub as well, which is also great to provide feedback, to send in feature requests or send in bugs or send in ideas you want to see inside the language as well. And I'll make sure to share the link towards those open source links on GitHub as well at the end of this session. So last slide, before we dive into the demo, it's a question that I get a lot, specifically when I talked about Bicep in the early days, is how well is Bicep really adopted? If you think about the ARM templates and the ARM language having been out there for many years, how well is Bicep really adopted, and how many resources are essentially really deployed using Bicep? So you might not be surprised that Microsoft is not really keen on sharing that telemetry data, right? So that's not something that they do regularly, but they did, and that's what I want to share with you today as well. So they share some telemetry data in terms of the number of resources deployed using the Bicep language over a period of 30 days. And they shared this statistic. So this is 1 million resources deployed using Bicep, and this is already back in May 2021. So why did we select that year and month? That is the first production-ready version of Bicep, was the 0.3 version. But already 1 million resources were deployed using that language, which is quite a lot if you consider that the language was just in GA a couple of weeks at that point. But later on, in August of 2022, it turned out to be 22 million resources that are deployed using Bicep. And that is not cumulative, that is not adding up the numbers, right? That is all of the resources deployed into a period of 30 days within that month. And the last statistic that we got, it's already a couple of months back from last year, but 61 million resources in September of 2023. So that's a lot, right? So this diagram, of course, does not tell us how many resources are deployed using ARM templates or other technologies. That's not really interesting about this diagram. This diagram really shows you the adoption rate when it comes to using this language to deploy resources in Azure. So with that out of the way, and hopefully we've laid some foundation for everyone joining this call or watching this later, it is now time to take a look at some demos. So we'll take a look at how to get started with Bicep from scratch. So I'll show you a couple of ways to get started with your first template to get the most out of VSCode when it comes to using that as a code editor to get the best authoring experience as well. We'll talk about the concept of modules. And we'll take a look at a large-scale deployment and some use cases around that. And we'll end up with deployment stacks, which is a new way of deploying resources joined as a logical group, as we'll see. So if you have questions, if you joined live, feel free to send them in the chat. I'll try to monitor that during the live demo as well. So let me switch to VS Code. And let's start with the first set of demos. So I have an empty Bicep file here. The first thing, if you haven't done that already, is take a look at the extensions, search for Bicep, and install the Bicep language, the extension, right? It is a really helpful way to get additional coding support. So how to get started? Let's open up the first Bicep file here. So to start declaring your first resource, so again, it's a declarative way, so not imperative, we need to declare what kind of resource we want to create, right? And so line 1 already gave it away a little bit. We're going to create a storage account. So the first thing we do is we use the keyword storage, followed by a symbolic name, and I'll get to that, what that is in just a second. But then we specify what we want to create. So that is that storage account we mentioned. We need to specify the API version. We'll do an equal sign and we'll do a couple of brackets. Now what we define is a couple of properties that are needed for this storage account. So you can imagine that we at least need to specify a name. So let's call that Cloud8. We need to specify a location. Let's do West Europe. That is where I'm at. Oh, sorry. And we need to specify a SKU, which is actually multiple properties, but at least the name, and we'll do premium LRS. And the last thing is a storage kind, which is blob storage. And that's it, right? So within a couple of seconds, I have now declared this resource. I could now pass this Bicep file into Azure and have this storage account be created, just like that. So of course, there's much more to it when it comes to parameters and deployment methods. We'll talk about that, but this is in essence a super fast way to declare your first resource. And as you saw, the code extension really helps you to get these values without having to know exactly which properties are needed. A more interesting way and a more even faster way is using scaffolding. And that's even faster than we just saw. So similarly, again, we're going to type in resource. We'll do a unique symbolic name here. And we'll say we'll do a storage account with an API version. And this time we're going to select required properties. So what that does is it scaffolds out all of the required properties without me having to know which properties are mandatory, without me having to go to docs pages to actually look up what is required. I can just now add the names, add the locations, the SKUs, the kinds, etc., and I've declared it. That's a concept of scaffolding. Now, of course, this is a very small and very easy resource within Azure, the storage account, right? But you can imagine having a very large one, which is ideal to do that using the scaffolding way. And the last one is it's code snippets, and that's even faster, especially for larger resources. So again, actually, we're not going to do resource, we're going to do ras dash, which provides us with a list of all of the resources I can deploy using what's called a code snippet. So what is a code snippet? Is a predefined set of parameters, values, etc., that allow us to create this in an easy way. So let's select, for example, the application gateway here, hit enter, and I now have the entire declaration ready to deploy, right? Not only that, I can use tab to tab within these values to actually select what I want to have to make sure that all of these properties have some kind of value I want. And I'm then done with declaring my resource, just like that. So that's code snippets available in VS Code and Visual Studio itself as well. So that is, starting from scratch and creating your first resource. The next thing you'll probably do is you'll probably start to add parameters. And the reason is if you start to add parameters, your code becomes reusable because at deployment time, you can change the values of these parameters to deploy something different using the same code, right? So params are quite easy to do as well. Use the keyword param, the name, the type, and optionally also a default value. So if I would deploy this now to Azure, it will use these default values, but during runtime, I can also change them to have a different host pool name, a different load balancer type, or whatever I want. So that is parameters. And just to show you the difference between JSON and Bicep, in case you're not convinced yet of the simplicity of Bicep, I could take this file, right-click it, and say build ARM template. What that allows me to see is the JSON equivalent of the same code. And if I do a side-by-side comparison here, you can see that I have left-hand side in Bicep 23 lines of code, where right-hand side, it is already 56, doing the exact same thing. Not only that, if you take a look at, for example, parameters, how easy it is to define those in Bicep, left-hand side, versus the complexity and all of the code complexity or overhead that you have on the right-hand side. Hopefully you agree that left-hand side is much more easier to read, to write, and to debug. So that's an example of what JSON looks like. Let's just get this out of the way. So when working with parameters, it's also advisable to take a look at parameter decorators. So decorator, as the name implies, allows you to decorate a parameter with some kind of option. So above any parameter, I can just hit the add symbol and then add in one of these parameters that are, one of these decorators that are available. So I put in a couple of examples here. For example, I can specify which values I can use and restrict to those values. Or I can restrict to a certain minimum and maximum value to have a range, for example, for an integer. Or I can have these parameters made secure so that they don't end up in any log files, etc. And of course, I should never ever do this hard-coded within the template, which is also why I get this error message from within the code extension as well, warning me about these secure parameters that should not have default values. So that's parameter files. That's parameters inside Bicep files. What I want to work towards is actually parameter files. So I have an example here, another example of a Bicep file with a set of parameters that we can define. So I could deploy this to Azure and provide values for these parameters and optionally override some of these values as well. But the other way is doing that using what's called a parameter file. So the parameter file, as the name implies, is only contains the parameters and the values I want to use, and the combination of the Bicep file and the parameter file, I can use that to deploy something to Azure. So before, a couple of months ago, you had to revert back to JSON. So this is a parameters.json file we had to use in combination with Bicep. So we were now just getting started to the ease of language with Bicep and all of the great benefits in there. And now suddenly we have to revert back to JSON for creating parameter files, which again has all of the syntax overhead, as you can see. However, a couple of months back, something new was introduced, which is called a Bicep param file. So that is the same language as Bicep, the same simplicity, the same keywords, etc., specifically for Bicep files. And again, if I do a side-by-side comparison here, you can see the difference in how easy it is left-hand side to define that versus what you have to do on the right-hand side. Also note that I'm using the using keyword here, which makes sure that the Bicep file and the parameter file are actually connected to each other. Why would you want to do that? It allows you to also have IntelliSense and code completion within the Bicep parameter file itself as well. So how would you create these? Would you create these from scratch? You can, but there's an easier way. So let me actually remove these files here because you can just right-click any Bicep file and say generate parameters file. You have the option to do the quote-unquote older JSON files or the new Bicep param files. We then have the option to do the required properties or all of the properties, and boom, there is the Bicep param file without me having to create it from scratch and enter in all of these values and names. So really easy to do, and again, a great benefit from the VSCode or Visual Studio extension that is available. When you are switching from using ARM templates towards Bicep, maybe you will have some experience in creating ARM templates, like I have, for example, of back in the day. At some point, you might want to take a look at existing JSON templates and decompiling those back to Bicep. You can actually do that right from within VS Code as well. So we have a JSON file here. So this is an ARM template, and this deploys a couple of Azure Virtual Desktop related resources. So if you're familiar, host pools, application groups, workspaces, etc. And I can just right-click this here and say decompile into Bicep. And there is the Bicep language equivalent of the same code. And again, it's much more cleaner syntax to read and to use. So that's a really easy way to reverse engineer or to investigate how something is declared inside Bicep. Another great way is actually inserting resources right into the Bicep language. And to demo that, let me actually switch to Azure. So I'm looking at any random resource group here. In this case, it contains a virtual machine, but this applies to any resource in Azure in general. So I open up this resource here, and what I can do is I can have the JSON view. So of course I can copy this, paste it into VSCode, and then do the decompile option, right, that we just saw. But the other option is actually to copy this resource ID, go back to VSCode, right click here and say insert resource, paste the resource ID, and within a couple of seconds, there it is. Here is the entire declaration of that existing resource in Azure, right? So this allows you to do great reverse engineering as well. If you have existing resources in Azure and you don't have the corresponding Bicep code, this is a super easy way to get that code. Now, of course, before this action, I had to authenticate against Azure, right? I did that in advance. That's of course needed to get that code, but this is a really easy way to do that. So the more you start using VSCode or Bicep language, the more sometimes you'll probably want to visualize what you are actually going to create. And there's a great way to do that within the VSCode extension as well. So this is, again, just another Bicep file with a couple of parameters, and in this case, 3 different resources. And to visualize what I am about to create, I can just click this visualizer button here. Let's just get this out of the way. And now I have side by side, left-hand side, the code, and right-hand side, the resources I'm going to create. This is also an interactive diagram. I can drag this around to make sure that it makes sense for me, or I can revert back to it. I can zoom in, zoom out, etc. And also have this as my documentation, for example, or to explain to someone else what I am about to create. This is, of course, a very simple example, right? But you can imagine if you have dozens of resources, it becomes very, very valuable. And we'll take a look at some examples in just a second as well. So that's the Bicep visualizer, also available in VS Code. Then when it comes to deploying resources, let me just open this Bicep file here. There's, of course, a lot of different options, right? I can take a Bicep file and I can use GitHub Actions or DevOps in Azure or PowerShell or Azure CLI or whatever I want to do. But in case you didn't know, there's also an integrated option right within VS Code to deploy it from VS Code itself. And that is something that's called the deployment pane. So if I click this cloud icon here in the top right, I get this deployment pane overview. And it's important to note that this is actually an experimental feature currently, so it's in preview at the moment, but allows me to specify my deployment scope, so the subscription and the resource group where I want to deploy this, and it allows me to specify in case I want to have a parameters file or specific parameters as well. It also allows me to change these. So for example, if I don't want to deploy in West Europe, but instead I want to deploy in the North Pole, just as an example, let's see what happens, right? We can change that right from within this deployment pane here. But the great thing, and even better, is that I can do a couple of actions right from within here. So I can do a what if, I can do a validate, and I can do a deploy. So let's do first a validate, which makes sure that my code is valid. And hopefully, you've probably realized that this is now not valid code because the provided location North Pole is not available for this resource, which makes sense, right? So let's revert back to the default, which is easy thing to do. Let's do the validate again, and the result is now succeeded. So it validated my template, it is correct, and I am able to deploy it. The next step I probably want to do is run a what if. And in case you're not familiar with what if, as the name implies, it tries to do a deployment without actually deploying it and comes back with what would have been created, updated, deleted if you were to deploy that Bicep template. So a really great way to test drive what the result would be from this template. So again, we get this result here with all of the resources, resource ID, and the changes that are about to be made if I were to run it. And lastly, I can also deploy it right from within VS Code. So the template is now handed over to the ARM engine, and within a couple of seconds, it is now deployed. So these are the resources that now have been created. with the resource types, the names, and the states. What's even cooler is that these also have hyperlinks, right? So I can click one of these links, it gets me to the Azure portal, and it gets me right to the resource that I just deployed. So I can prove that by going back to the resource group and, for example, opening up this deployment overview. We can see that this is the date and time of just now. It took a second to complete, and this was the deployment that actually took place with the deployment details and with the resource that I was just created. So right from within the VSCode console, I was able to deploy that and have the resources be, in this case, created in Azure. So of course, this is not ideal for large production environments where you're dealing with, approval processes and all of that. But as a developer, if maybe I'm coding towards a test environment or a staging environment, it's super easy to deploy it, test it, change it, redeploy it right from within the VS Code console. Right. So that was the deployment. And the last thing inside this part, before we move to some of the more advanced stuff, is the concept of modules. So modularity, as I explained in the beginning, is a big part of the Bicep language itself, right? It allows you to, as I mentioned before, extract pieces of code, put them into separate files in order to reuse them for other projects, for other environments, or to share them with other people. So let me show you an example. I have a main.bicep file here. And again, it contains code we have seen before, right? I have a couple of parameters. I am creating and defining a resource. But here is the module concept. So instead of using the keyword resource, I'm now using the keyword module, followed by that symbolic name, and followed by a file name. What I then specify is the scope. It's called RG. So RG is one of those symbolic names, the one in blue, which actually reverts back to this resource that I'm creating inside the Bicep file as well. And this resource, as you can see, is actually a resource group. So by doing this, I'm basically stating that all the resources that are declared in this file need to be deployed in this scope, so meaning in this resource group, and using these parameters. That's the way to use a existing module. And by the way, to create this resource group, I also used this statement here in order to have it only deployed for certain conditions. So this is a conditional deployment stating that only deploy this resource group if, for example, this Boolean is set to true, something you can also do within Bicep. So this file here, this 8 VNet module Bicep file, if we open that up, because it's on the left-hand side here, this is just another Bicep file, right? There's nothing different between a module file and a Bicep file itself. These are exactly the same thing. So I could just take this file, deploying into Azure and see the results. But in this case, I'm using it inside my main.bicep file to reuse that module. Similarly, I'm also using multiple modules. So I have a module here for VNet that we just saw, but also for virtual machines. In this case, also for Azure Virtual Desktop. And I'm also using a for loop to have multiple of these modules be deployed into multiple different resource groups. So this concept also allows you to deploy resources into different resource groups. And the reason we are able to do that is we scroll all the way up. We have something that's called the target scope, which is set to subscription. So if you are familiar with ARM templates and deployments of VSCode, you might know that there are different target scopes you can deploy to, starting from resource group, going to subscription, to tenant, all the way up to management group as well. So if I want to change the default, so by default, you will always deploy all resources into a single resource group, which is of course something you do not want to do. You want to separate those out based on, for example, their lifetime. To do that, you set it back. You set it to subscription, and that allows you to have different modules deploy into different resource groups. So in this example, I only created a single resource group, but you can imagine I would have created, I don't know, 3 different resource groups, and all of these modules point to different resource groups to do their deployments in there. And we'll actually see that in an example in just a second as well. So that's the concept of modules, a high level. So let me just revert these changes here. So I just pause for a second real quick to see if there are any questions in the chat. I don't think so. So if you do have questions, feel free to use the chat. But for now, let's move on to some more advanced topics. And these are part of the part 2 that I created here. And the first thing is that I promised to take a look at is a large-scale deployment. So again, I have that main.bicep file here, indicating that I'm actually using modules, right? I have that same target scope set to subscription. So in this case, I am actually going to deploy into multiple resource groups. I have a large set of parameters, right? Because this is a very large deployment. And as I mentioned before, in this case, I am actually creating multiple resource groups here by also using a postfix and a prefix to have some kind of naming convention also be applied to these groups. And once that is finished, all the way down here starts the concept of modules. So I use that same keyword module followed by the symbolic name and pointing to, in this case, 6.1 AUD backplane module.bicep. So I'm passing that a subset of the parameters that I collected above to make sure that this module has all of the values that it needs to deploy the resource that are defined in there. So similarly, as you might have imagined, I have a module for networking. I have a module for Azure Virtual Desktop monitoring or log analytics, one for shared image galleries to be created, one for file services, key vaults, etc., etc. So left-hand side, all of those files that start with a 6, so 6.1, .2, .2.1, etc., those are all module files I use within this main.bicep file. Now, it's not mandatory to have these named with 6.1, 6.2, 2.1, etc. The reason I did that is that I can actually have an overview of how these are nested, right? Because within 6, I use, for example, 6.2 as a module, but within 6.2, I use, let me scroll down, 6.2.2 as a module. So that is how they are all nested together. That's the reason I did that with the naming convention. But it's an optional thing, something that I prefer to do. So let's take a look at how large this deployment is. So this is the Bicep file and is about 400 lines of code, which is already quite large. But if we take a look at the JSON equivalent, we have to scroll all the way down because this template is over 2,000 lines of code. So that is not only code complexity, as you might imagine, but it's also because the JSON file actually crams in all of the modules inside the JSON file as well. So this is just one giant large JSON file containing the main declarations as well as all of the modules that we are using. So now it becomes interesting to actually see a visualization of what that would look like, right? So let me right-click this Bicep file here and say, open the Bicep visualizer. So this is the end result. I'm realizing it's not readable, but let me zoom in to show you what what kind of level of detail you get inside this visualizer. So it's also module aware. So everywhere where you see this folder icon, that's actually a module containing different resources. So we have one for our auto scaling, one for our Azure Virtual Desktop backplane, one for our networking with peering to VNets and all of those integrations. We have a shared image gallery with an image definition, templates, galleries, resource groups attached to it, etc. We have one for our data, so for our storage, our profiles, our software, our scripting, our key vault, in which are going to store a couple of secrets that are part of this deployment, and a set of workspaces and log analytics and resource groups, right? So now it becomes really valuable to actually see what you are about to create and have this Azure documentation for other people to look at, or just for yourself to get an idea of what we are going to create. It's also interactive in a way that if I were to make a mistake in one of these modules, it will actually show up red in this diagram as well. So if I made a typo in one of these modules, you can also use the visualizer to pinpoint where it went wrong inside your code. So that's the large deployment that I wanted to show you. So I want to spend the last 10 minutes or so to talk about deployment stacks that we also promised. So deployment stacks, let me scroll down to get that example. That's not it. Where is it? Here it is. So deployment stack, what is that? It is basically a logical grouping of different resources into what's called a stack, right? So what are some of the reasons why you want to use a deployment stack as part of your deployment? It allows you to, first of all, specify which resources are part of a logical group. That in itself is an advantage, but the other advantages are that you can define that no one else can remove resources from that stack, even if they have all of the permissions you can imagine in Azure. So let's say that I am owner of a subscription. I cannot remove one of these resources because it is part of that logical group, and because I want to prevent that someone accidentally removes a resource that is actually dependent on other resources as well. So the deployment stack enforces you to update, remove, delete all of the resources using the deployment stack itself. And that is to make sure that all of these resources that for whatever reason are part of a logical group are always maintained, updated, and deleted using the deployment stack as well. So in order to create a deployment stack, this is, for example, the Azure CLI commandlet. There's PowerShell in this script as well. But you basically do AZ stack group create with, of course, a name followed by a resource group. So that is where the deployment stack resource itself will live. And the Bicep file, which contains all of the resources that should be part of that stack. And this is that deny option. So in this case, I specified deny delete. So no one can delete resources from this deployment stack. So what does it look like in Azure? Let's switch to that. This is that resource group, and I just deployed it earlier towards that resource group. So I have the option left-hand side here to take a look at deployment stacks. If I open up deployment stack, here's that stack that I created. I guess that's yesterday, right? So if I open up this stack, I can take a look at what's inside it. And of course, I can see the resources that are part of this stack, which is an Azure Virtual Desktop use case, right? So application groups, host pools, workspaces. And I have the option to also delete this entire stack. So that is similar to, if you're familiar with Terraform, the Terraform destroy option to create, to delete resources that are part of some kind of logical group. In this case, the resources all reside into the same resource group, but this stack could also overlap different resource groups, or maybe even overlap different subscriptions as well. So I could delete all of the resources that are across all of the different resource groups by just deleting the entire stack. What are some of the options here? I can do a detach, which means that all the resources will still be available, but they are only detached from the stack. I can delete all the resources and detach the groups, or I can delete both the resources and the resource groups, which is, of course, the most fun option to do, right? So if I do a review here, I can actually get an overview of what is going to be deleted, and I can confirm that this way as well. So I mentioned that deny option, right? So here's the deny option. So deny setting is set to deny delete. So how does that work? If I go back to the resource group, and if I try to delete this application group here, and yes, I am an owner of this subscription, so I do have the permissions. Oh, let's just copy that in. Delete. It actually comes back with an error stating that I do have permissions to perform that. However, the access is denied because it was part of a deployment stack with the stack name, the ID, etc. in it. So although I have all of the permissions in this subscription, I cannot delete it because it's part of that logical group. So that's one of the advantages that you get as part of the deployment stack. Of course, I can also go in and take a look at, the deployment of it. So I can go ahead and edit the deployment properties by making the changes in terms of detach and delete and the options in there as well. and all of the options that are part of the template that is behind that. So that is part of the concept of deployment stacks. So if you are familiar with Azure Blueprints, something that's been out there for some time as well, the current advice is actually to move away from blueprints and start using the deployment stacks. So I personally never really was a fan of blueprints, but you might have used them or seen them somewhere. The general advice is now to move towards deployment stacks. In fact, my advice would be to always use deployment stacks because of all of the benefits that I just explained, and because you start to create logical groupings of resources that allow you to make sure that all the resources are connected, even if they are across different resource groups, different subscriptions, or possibly even different tenants. So that's the concept of deployment stacks. With that, I think we have about 5 minutes left. So for those of you who are also transitioning to other sessions, I want to make sure that you have the time to do so. So let me go back to the slide deck and wrap it up. So these were the demos that we just did. There was just, every demo that I can cram into the 45 minutes or so we had for the demo sections. But if you have additional questions, feel free to reach out using the channels that I mentioned before. But I want to give you a call to action, right? So if you're interested to get started with Bicep, these are a couple of links, right? And I can share them in the chat, of course, later as well. But there's, lots of documentation, right? AKA ms/bicep. But also very interestingly, there is a Bicep monthly community call, which is something that the product team in Redmond runs every month. It's open to anyone, so it's not specific NDA, MVP audience or whatever. Anyone can join if they sign up. And during that monthly call, you get a monthly update on all of the new stuff that has come out for Bicep, and even sometimes things that they are working on or want to get feedback on, etc. It's a very active, very fun community, and I can encourage you to sign up for that. Number 4 is the Bicep GitHub location. I mentioned I promised to mention that it's GitHub/Azure/Bicep, which contains all of the code and allows you to send in pull requests, errors, and all of the things you would like to see in the language. And lastly, there is also a Bicep learning path. So if you want to go beyond the 45 minutes that we were able to spend together today, take a look at these Bicep learning paths, because they allow you to test drive the Bicep language inside the sandbox, the VM, to test your template, to see the results, maybe even use that VSCode deployment pane to start deploying it, start test driving it. So that was it. So hopefully that was interesting to you all. Again, if you have questions, feel free to reach out using Twitter, email, LinkedIn. Happy to connect and talk about this and other topics later as well. And thank you for joining. Have a great day, and see you hopefully next time.